Okay, like always, before we start our lesson, we're going to do a warm-up. So go through, solve these three equations for y, right? We're solving them for y this time. And pause the video and go ahead and go to work. Okay, so answers for our questions here. Number one, we solve it for y, we get y equal to 1/2 times x plus 2. Second one, y equals 3x minus 2. And the third one, we get y is equal to negative x minus 2. On to our lesson today, which is going to deal with rate of change and slope. So we want to be able to find the rates of change from tables and also be able to calculate slope. So rate of change, what it does is it gives us kind of a numeric relationship between two quantities that change. And so to illustrate that, we have a little bit more of a mathematical definition here of what it should look like. So we have rate of change, and you notice here what it's equal to. Change in the dependent variable. Now, the dependent variable is the variable that is on the y-axis, right? The vertical axis. Whereas the change in the independent variable, that is our x-axis. Okay? Let's look at some more examples of this. So if we have this table and we're trying to find the change in elevation of a hang glider over a period of time, we want to know whether it's constant, and we also want to know what that rate of change is going to represent. So, starting out, let's write our rate of change, and let's also identify what is our independent and our dependent variables. So our dependent variable goes on the top. Okay, that is in my y direction. And so we'll signify the dependent variable as elevation, okay, which would be on our y-axis. And time, almost always, time will be in your x-axis. And again, in a table, most of the time, the independent variable will be in the first column and the dependent will be in the second column. All right, so to calculate the rate of change, we are going to find the difference between our rows. Okay, so we'll want to find the difference between these two values, okay, and the difference between these two values. Let me show you what that looks like. So we'll take 325 minus 360. So I'm taking 325 minus 360. Okay, we'll describe this a little bit more when we get to slope. Okay, but I want you to just pay attention how I'm doing this. 325 minus 360, and I like doing it again with arrows. And on the bottom, for our independent variable, we're doing 2 minus 1. So over that period of time. So if I simplify this, I find that I get negative 35 over 1. So start thinking about what does that mean in respect to the context of this problem. And don't take the calculation for just one set to be accurate to determine whether it's constant. We're going to do this again for a second set of rows. Okay, so the next set will be from 3 minutes, or from 2 minutes to 3 minutes. And we'll look at what our change in elevation is, do the calculations and simplify. Now it looks to me like they're constant, but again, I don't know that for sure. I still need to look at another set here. So let's do that. And we'll take the 255 minus 290, 255 minus 290, and 4 minus 3. Do our calculation, we get the same thing. So what that tells me is that our rate of change is constant and is equal to negative 35 feet per minute, or another way of saying that more in the context of our problem is that our hang glider is descending or going down at a rate of 35 feet per minute. Okay, good job. So now let's look at slope. And a lot of your teachers are going to tell you that slope and rate of change are the same. And it's true. They really are measuring, and the calculation is the same. Okay. Vertical change, again, this is again in our y direction. our horizontal change is in our x direction. Okay, and we sometimes call it rise over run. Okay, for finding slope. So let's go ahead and apply this, right? And we're going to use this using a visual tool, a graph, right, rather than a verbal representation. So I wanted to find the slope of the line that's given here, and they've also given me already 2 points that they've located. Okay, great. That actually helps me a little bit. So I'm going to start at 1 point, and I want to count in the vertical direction to find the rise. Now in this example, we're starting over here on the left and counting the rise. So if I look at this, I'm going up 1, 2, and 3. Okay, we're rising up 3. And then we'll go and turn the corner to get to our other point right here. So I'm going to turn the corner, and I'm going to start counting my run. So horizontally, my run is 9, right? And I'm going backwards 9. I'm going to show you a second way that I prefer actually teaching this, especially to my tutoring students. I actually have my students start with the leftmost point, just like as if you're reading a book. Start at the left and go to the right. So I teach students a lot of times to start here, and you're either going to go up or you're going to go down to get to the next point. Okay, in this case, I need to go down, right? Just like I did here, I'm going to go down 3 units. So I'm going to go down 3, and then I'll turn the corner to go to the next point. And I will always do that. If I start at this point, I'm either going up or going down, and then always going to the right. Okay, so then if I went to the right, I would go here, and I'd go, make that 9 units, right? 9. Okay, so when I put that in the form of my slope equation, or slope formula, I have 3 divided by -9, using the way we started. And if I simplify that, you notice I get -1/3. Now, I have a lot of students that question, well, why is the negative sign not on the bottom? This negative sign could actually be applied in any one of 3 places. Think about it this way. Fractions are division problems. So if I do this, if I say a positive divided by a negative, it still results in a negative. So I can pull that negative right out front here. And I get a slope of -1/3. I'm going down, and it tells me the steepness of that is -1/3. Gives me kind of a numeric value for the slope. Okay, let's try this one. I'm going to let you work this one on your own. Go ahead and pause the video and work this out. Okay, see how you did. So doing what we did the last time, we find our rise, we find our run, we put it into our calculation for slope. Okay, remember the change in the dependent variable is always on the top. Okay, always on the top. And our change in our independent goes to the bottom. We do our calculation and we get -2/5. Okay, and again, this is a great tool for measuring the steepness of something, whether it's a roof, a ramp, or a mountainside. This slide I really like. It kind of puts everything together just a little bit for you in terms of slope or rate of change. And what it tells us of is if I have a line that rises from left to right, I have a positive slope. Okay, the slope, the answer that I'm going to get should be positive. If, on the other hand, I have a negative slope going down from left to right, I'll have a line that looks like this, and that's negative. But I could also have a 0 slope, which is telling me that there is no change. Put this, no change in the y direction, right? I'm not going up or down in the y direction, also known as my dependent variable, okay? And that would be a 0 slope. And the other type of slope I could have is what's called undefined, meaning this time that there is no change in the x direction, okay, which is my dependent variable, okay? No change in my dependent variable. And so I get an undefined slope, right? Or no slope. Or you can even put NA. Okay, all those will work. So let's say you don't have a graph. You don't have a visual of the line, and all that you're given is the coordinates. Okay, we can still find the slope, and in some cases my students prefer this to the graphing method. So here's what we need to do that. We need a formula, right? And you recognize this already. We had that at the beginning of this lesson. Rise over run is our slope or rate of change, right? I call it rate of change, ROC. But we can calculate it right here if I'm given coordinates. Notice what I have. An x2 and a y2 and an x1 and a y1. And again, I have my dependent variable on the top, my independent variable on the bottom. Okay, and one thing I try to help students remember, because this is a place where we make mistakes a lot of times, try to tell them, remember, y is to the sky, x is down in Texas. Y's to the sky. X's down in Texas. Okay? See if that'll help you remember. Now, I'll also tell you, notice I have x2, y2 at the front, x1 and y1 at the back of my calculation. If you flip those around, you can still get the correct answer. Okay? So there is some leeway here. Just don't mix them up. Don't do a y1 minus y2 and then an x2 and minus x1 on the bottom. That would give you a mistake. Okay? So let's practice this. Using points, we want to find our slope here. Now, the slope formula, y2 minus y1 over x2 minus x1. There are two things that I work with a lot of struggling students with to help them slow their brains down, or if you're a new learner to calculating slope. I encourage my students strongly to label those points. Okay, x2, x1, y2, y1. Okay, and if you don't like that, flip them around. Make this. Make it x1, y1, x2, y2. And then also write the formula for every problem you're doing. Now, I agree. Sometime you're going to get really, really good at this and maybe you don't need to write it. But if you're starting out, I encourage you to write that slope formula down repeatedly. Okay, so let's go ahead and fill this in. If I substitute those values in that I labeled, then do the calculation and simplify, here's your slope. Okay, the key part here is getting from here to here. Okay, if you can get those substituted in correctly, I know arithmetically you guys are good, you won't have a problem. This is where errors are made. Okay, getting them in the right places. Okay, so we end up with a slope of negative 2/3. So I'm going to give you some practice ones on your own. So start with this one. Go ahead and pause the video and work this out. Okay, we're back. Let's see what you did. You should get an answer of 0, which might have made you question whether you were doing it right. It is possible to have a 0 slope, and I want you to think about what that slope would look like if I graphed it. Okay? All right, let's try another one here. Go ahead and pause the video once again and calculate your slope. Okay. Here we get, for an answer, this time we end up with 3. Now we're going to go ahead and simplify this to 3 out of 3 over 1. There may be times that we want to leave it like this, and if you do, that is still correct for me. So on this one, calculate the slope, a little bit of a multiple choice question. So if you're still having a little bit of trouble, you can try it, and you've got some answers you can refer back to see if you've got it right. So go ahead and pause the video and work through this. Okay, so your answer should be on this one. Answer D, negative 4 over 3. Don't need to do that. There we go, get that off of there. So negative 4 over 3 is what you should get. Okay. All right, So let's talk about slopes of horizontal and vertical lines. We talked about this a little bit before. In a vertical line, we end up with an undefined slope. Okay, we can't divide by 0. And in a horizontal line, we're going to end up with a slope that is 0, right? We're dividing 0 by some other number, and that's okay. All right. So we'll leave you there at this lesson. Good work. If you have questions, bring them in, email me, and we'll work through them.